Today, we will introduce you to a very important concept, which is polarity. So, I just want to relate my beginning of my class today with something in real life, which is a concept of polar and a concept of non-polar. And at that point, you can see that we're dealing with the two opposite concepts since we have polar and non-polar. Let's go to the real life thing. The polar concept is special in chemistry, and an example of a polar thing in chemistry is the water. And the non-polar thing in chemistry, as an example, the oil. For example, like olive oil, any oil in general. But my question is, if we mix the polar thing with non-polar thing, what will happen? If you mix the oil with water, I'm pretty sure that you made this experiment in your life. So if you make it, you'll notice that we have two layers of water in here and the oil above. And at that point, we can say that the oil and water are not mixed together because this one is polar and that one is not polar, right? And we can end up with a new rule in chemistry says the like dissolves like. In other words, since we're dealing with the two opposite, like polar and non-polar, they're not dissolving each other. And we have a beautiful concept which is immiscible. Immiscible means they are not mixed together. So what will happen if we have a polar thing with polar thing, like A and B? A and B are polar things. Are they dissolved in each other or not? We can say since they are polar here and this one here is polar, then they should dissolve in each other. Based on the rule here says like dissolves like. Since we have polar and polar are alike, and that's why at that point we can say they can dissolve in each other. A and B are miscible, which means that they are dissolving each other, which is the opposite of immiscible. So if you want to take the opposite of miscible, you have to add immiscible, like IM, in order to make reflect the concept or the meaning. And the same thing is repeated. Once you have like A and B, both are non-polar, and at that point they dissolve in each other. And by the way, if you want to make this experiment in your home, you can bring let's say olive oil with a corn oil and mix them together. Since they're different from each other, but at the same time they are non-polar, then they are dissolving each other. The question now, what makes A and B non-polar? What makes A and B in here polar? So, is there any rule in that? How can we do that? What is the most important thing? Let's go there. What's the meaning of polarity? Like, okay, we know like oil is not polar, water is polar, but why water is polar? What is the meaning of polar? What does it mean? So, let's take a simple example in here. If you have a compound in chemistry, which is a general molecule and actually presents in your stomach, HCl or hydrochloric acid. First of all, it looks like HCl. We have a bond in here, like a single bond. All right. First of all, you have to say that the chlorine atom contains 17 protons and the hydrogen contains only one proton. And at that point, we can see that we have a lot of positive charges for a chlorine atom, and here we have like only one positive charge. At that point, we can say that we have two electrons in the bond between the HCl, and there's attraction force between the positively charged protons and negatively charged bonding electrons. And at that point, some of these electrons will align a bit to the chlorine, and that's why the chlorine becomes partially negative. This sign that looks like S means partially negative, which means that there will be a concentration of the negative charge on the chlorine atom because the chlorine atom is more electronegative. So the electronegativity is defined as the power of an atom to attract the electrons in the bonding towards itself. And at that point, since we have partially negative, we have partially positive for hydrogen. And since you have partially positive and partially negative, then you will have a di, which means two pole. And then that's why we have a dipole. And since you have negative and positive, this is a pole like south and north, okay? And di means two. And that's why this is the polarity comes from. Since you have a partially positive and negative in your compound, at that point we can say that the HCl is polar. Okay. But if you have a polar bond like HCl, does this mean that your compound totally apolar or not? I just want to explain this a bit. At that point, I want to talk about the geometry of molecule, and it's discussed in previous class, and you can go to the video in the link in the description box down below. If we take, for example, like BeCl2, I'm not going to revise the previous class. You just go to the link down below in the box and just go to the geometry of molecules. The Be is a linear in combination like Cl, and this one here is Cl. And since the chlorine atom here is in group 7, it contains 17 protons. And for beryllium, it's in group 2, it has 4 protons, and this one is 17. At that point, we can say, if we take this bond in here, okay, and this bond in here, you have 2 bonds in this compound. From the previous example, we can say that the chlorine atom is more electronegative than beryllium, and that's why it will carry a partially negative, and beryllium will catch a partially positive. And if you go to another bond in here, this one will be partially negative, and for sure this is partially positive. If you ask me about what will be the direction of dipole, the direction of dipole indicates to the direction of the more electronegative atom, okay, the strong atom, to the partially negative. So if we want to describe that in terms of an arrow, we can say you have partially positive and partially negative. The arrow should be going to the negative part. And if we go to the second bond, we can say that it comes to the negative one here. It goes to the most electronegative atom. And since you have 2 identical atoms and the arrows are opposite to each other, then this compound is non-polar. And at that point, we can conclude that since BeCl2 is linear with identical atoms, I mean like identical surrounded atoms, like you have both Cl and Cl, then this one here is non-polar. Let's take another example, like H, C, triple bond, N. At that point, you can see that you have different atoms. From the periodic table, the nitrogen atom is more electronegative than the carbon, then it's partially negative. This one here is partially positive. If you combine those together, and if you combined this bond between the carbon and hydrogen, this one will be, like carbon is more electronegative than hydrogen, then it's partially negative with respect to carbon, and this one here is partially positive. And now if we take the direction about the arrows, you can say that you have, this one is going to this direction because this is partially negative and partially positive. And with this bond in here, the direction is going there. So at that point, since you have a linear, okay, but the atoms are not the same. You have nitrogen here and you have hydrogen. So if you have different atoms in a linear form, and you can see that there is a net resultant, the direction of the arrows are on the right side, then HCN is polar.